All right, welcome back, everybody. Here we are beginning chapter 3. Now, I work through chapter 3 slightly different than other teachers and than our textbook does. I like to do translations first. Translations I tend to think of as the simplest transformation. So we're going to see how translations work to begin with. So go ahead and open up your packets to page 9 with me. You can go ahead and take a look at understanding this with me. Now, for this exploring reason, you kind of really have to be in class to do that. So we're actually going to go right on to a definition of a translation. A translation, all the details here are here, and you can read it here, okay? If you do a translation, you actually use this translation rule. And we're going to talk about that translation rule in just a second by applying it to this. Translation is just a slide of an object. So if I take this ABC figure and I slide it down here, it's going to land in these points. That'll be A prime, B prime, and C prime. You can always tell where the start is because that's our original points, and where the result is. Those are the prime points. If we move this again, let's say over here, then these points would have a double prime. It would be A double prime, C double prime, and B double prime. All right. Now, with that taken care of, let's go ahead and see how we can think about this as a transformation. So if I take a look at each point, I can actually notice that they move starting here, and they go this way and then down. Okay, that's how to go from A to A prime. It is the same pattern from B to B prime. So I got to go over 4, and then I got to go down 6. Here I could go over 4, 1, 2, 3, 4, and then I go down 6, 1, 2, 3, 4, 5, 6. So looking at this, for each one I'm translating over 4, I'm translating what's called left 4 and down 6. Now, if I went the other direction, if I went up 6 and right 4, I wouldn't be starting here. I'd be starting down here, and that'd be kind of the backwards direction. See, a translation tells us where to, from where to start, how to get to where we end. If we go backwards, it's kind of the backwards translation. That's not what we're trying to do. Now, because we're doing this translation, left 4, if I take a look at the x-coordinates, what's happening is they're subtracting. I'm getting smaller in my x-coordinates. So rather than just left 4, I could also say that this is minus 4. And the same is true for my y-coordinates. Because I'm going down 6, I could do my y-coordinates as negative 6. And that is true for every single one. This is minus 4, minus 6, minus 4, and minus 6. Okay, or negative 4, negative 6. So in each case, we're going left 4, we're going down 6. So how would we write this translation out? Well, we would write it like this. Start with a T, capital T, and then we would actually write the transformation in vector notation. Now, if you've taken physics, you would know a little bit about vector notation, but it's just a quick way to describe the transformation across an axis. So here, since we went left 4, we could write it like this. And I'm actually going to write it right over here. X minus 4. And then the y value, I go down 6. So I put y minus 6. That would be my rule as a vector. And then I apply that rule to my input, A, B, C, to produce an output, A prime, B prime, C prime. Now that's my general rule. I can limit the rule, though, and write it like this. I can make it with a little less detail because I know if I think about my coordinates, here's the x-coordinate, so I don't really need that x. Here's the y-coordinate. I don't really need to write that y. So I can write it like this. Negative 4, negative 6. Apply that to figure A, B, C, and I get A prime, B prime, C prime. That's how I can write my transformations. Pretty simple idea. Translation says you're going to slide it, and then in order to slide on a 2D plane, we need to move over the x-axis, and then we need to move over the y-axis. Think about this. What if these were slightly different numbers? What if this was positive 4? What would happen? What if this was positive 6? What if this was 0? Okay, so think about that real quick, and we'll talk about it. Well, If this was positive 4, then we would move to the right 4. 1, 2, 3, 4. And then we would go down 6. 1, 2, 3, 4, 5, 6. So this would be our new A. Same would happen to B, same would happen to C. If we just change that to a positive 4, if we change this to a positive 6, we would, instead of going, we would still go left because it's negative 4, but the positive 6 would tell us to go up. So our graph would end up with a triangle over here. Okay? Now, negative 4, negative 6 tells us the directions to go. Finally, if it's 0, then we just don't move at all. So maybe this says negative 4, comma 0. Well, then I would go left 4, but then I wouldn't go down. I would just end right there. That's how our transformations work. That's how our vector notation works. All right. With all of that said, let's go out and practice it. Let's see if we can do so. So here's our transformation rule. You'll notice it's written in that vector notation. We're operating on this input to produce this output, okay? So we want to take triangle EFG and we're going to translate it with this rule. Notice that we have this part which tells us to go right because that is our X and Y. The X part says go right 7. The Y part tells us to go down 4. Okay? So we're going to go right 7, we're going to go down 4. Let's go ahead and do that. So I'm going to take my highlighter here, go right 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to go down 4. 1, 2, 3, 4, right there. Now I can do that to F. I'm going to get my new F point right here. This is my F prime. Okay. Now, I could take E and do the same thing. Go over 7 and then down 4. Or I could just think, because this is a translation, I'm just sliding the object. So it's not going to change its orientation. It's not going to change its size. So if I look at F to E, that's going to be the same here as it is here. So I can even start at F and kind of down 1 over 4 to get to E. So if I go down 1 and I go over 4, I'm going to get to E prime. And this is E prime. Okay? Notice that's the same count. 1, 2, 3, 4, 5, 6, 7. I go right 7. 1, 2, 3, 4. Down 4. I can do the same thing with G. I can count over and down, or I can go ahead and just think about how it relates to the other figures. This time I'm going to go over 1, 2, 3, 4, 5, 6, 7. And then I'm going to go down 1, 2, 3, 4. Boom. All right, and this is my point, G. Boom, boom, boom. We've got our nice triangle here. Okay, so now, oh, by the way, that's G prime. Now, what happens to the coordinates? Well, let's take a look at our coordinates. So let's start with F, and I'm going to write the coordinates here in brown. So the coordinates of F are -1, 5. I can do that because I read on the x-axis it's -1, and then it goes up 5. So it's -1, 5. My G coordinates are -2, -1. Okay? And then my E coordinates are -5, 4. So if I look at these and I apply the transformation to each of those coordinates, I can even get the coordinates of my new points. Now, of course, I could read the coordinates. It's not too hard to read them. But I want to see another way that I can get the coordinates. So I'm going to write it over here. Start with E. We've got the coordinates -5, 4. And if I follow this translation, translate 7, -4, okay, I'm going to apply that rule to this. And whenever I do that, I'm going to get my E prime. Okay, E prime is going to be just a set of coordinates. So if I apply that rule to this, I'm going to take my -5, I'm going to add 7 to it. -5 plus 7 is 2. Okay, and then I'm going to look at my my 4, and then I'm going to minus 4. Now the reason I'm getting the plus 7 is because of that 7. The reason I'm getting the -4 is because of that -4. This isn't an equation. I don't need to think about doing the opposite or anything like that. I just add or subtract. Those are my new coordinates, 2, 0. Let's go ahead and double check, make sure the coordinates are 2, 0. And they are 2, 0. Awesome. So if I apply the same transformation to f and g, I should be able to get their coordinates. Okay? So f is -1, 5. G is -2, -1. Okay? Sorry about that cough. Translate that. Translate that. Go ahead and do it yourself. Pause this video and see if you get the same coordinates that I do right at the end here. Pause the video now. All right. So hopefully you paused the video and you were able to get f is 6, 1 and g is 5, -5. I hope you were able to get those coordinates. Now, again, this is a way to just translate the coordinates, but notice how I didn't even need to use the graph to get these. That's what we want to do over here. So you've got two triads. What I want you to do is take the original points, E, F, and G, and I want you to translate them with the new rule. Now, each of these has a new rule, and I want you to translate E, F, and G with that new rule and find out what the new coordinates of E prime, F prime, and G prime will be. Write them over here. Now, I'm not going to do this with you. If you ever want to see it happen, just come in and talk to me during class or after class, and we'll go over it. Make sure you've got them. But you should be able to do that yourself by now. Again, follow those instructions to just add or subtract from our coordinates. All right, let's finish off translations with a few other things. What if we have a translation and we want to come up with a rule for it? Well, all we got to do is just what we did at the beginning. Make a slope triangle, make sure they kind of match up. Oh, t to t prime, u to u prime. Notice how each one is going down 4 over 1. 1, 2, 3, 4 over 1. So each one is following that rule, down 2 over 1, which means our rule is going to be t for translate. Then we're going to do our vector, -1, because each time we went left 1, and -4, because we went down 4. We're going to do that to STUV to produce S prime, T prime, U prime, V prime. Boom. All right, and finally, let's see, what's the translation rule to map P to P prime? Well, again, this is only 1 point, so it should be easier. Go ahead and write out that rule yourself while you pause the video. Let's make sure you can work on this to get P to P prime. All right, let's see if you got it right. You would do T, you would write your vector symbols. If you do your X, it goes over 5. So we would do 5, and then it goes up 2, so 5, 2. And then we would have applying that to P to produce P prime. There we go. All right, now these are some examples of translations. We should be able to do it visually. We should be able to write the rule down, and you should be able to describe the translation in words, okay? So you should be able to do all of those. And then the final thing I want you to be able to do is write out the coordinates. Now, something new we're going to do on this is by the end of each big idea, we're going to go back up to the warm-up and we're going to write down something that we can do with these. We're going to come over here. We're going to do translations. Okay. Now, these are the things you should be able to do with a translation. Write the rule. Write the rule. The second thing you should be able to do is get a rule. Okay, so you want to be able to write the rule. You should be able to get a rule by looking at the equation or looking at the graph. So we're going to say from a graph. And then our third thing, we should be able to apply the rule. In a graph. And fourth thing is apply the rule in or with coordinates. Okay, if you can do all of those things really well, you should ace this test. We're going to have some practice problems near the end of the chapter, so definitely work on those. But that's exactly what you need to do in order to succeed on translations. Have a good day.